Hi everyone, Mr. Thomas here, and welcome to the very first virtual chemistry lesson. I want to start today's video by doing a little thought exercise with you. I want you to go and find a random object in the room. Once you've found that object, have a look at it and try and work out what it's made of. So the object you picked up might have been made of metal, or it might have been made of plastic. But regardless of that fact, every single object in the known universe is made of atoms, the smallest building blocks of everything. In today's virtual chemistry, we're going to be looking at these building blocks as we investigate atoms, elements, molecules, and ions. So without further delay, let's begin. So let's start by looking at atoms, the building blocks of the universe. These are the smallest possible unit of matter that elements are constructed of. Inside the atom, you'll find three subatomic particles, subatomic meaning smaller than the atom. The first two of these subatomic particles you'll find within the nucleus, or the center of the atom. These are the protons, which carry a positive electric charge, and neutrons, which carry no charge at all, they're neutral. The last of the subatomic particles is the electron. This is found orbiting the nucleus of the atom. Electrons hold a negative electric charge, and because of this, it means that when there is an equal amount of protons and neutrons in an atom, it holds no charge, it's completely neutral. So that is the basic structure of an atom. However, the number of subatomic particles within the atom will change depending on what element it is. For example, here I have one hydrogen atom. The hydrogen atom contains one positively charged proton and one negatively charged electron. However, if I'm to change this to helium now, that contains two protons, two electrons, and two neutrons. So to summarize, atoms contain positive protons, neutral neutrons, and negative electrons, and the number of these subatomic particles will change depending on what element the atom is. So there are a lot of elements. Currently we've discovered about 118 different elements. However, there could be hypothetically more, such as element 119, unanenium. Elements like unanenium are completely hypothetical. We haven't been able to synthesize them yet. However, scientists don't know if there is a limit to how many elements there could potentially be. This is because some scientists believe that there is a limitless amount of elements. This is because all you need to do is keep changing the number of subatomic particles within the atom and therefore discover a new element each time you increase the amount of subatomic particles. However, we're jumping the gun a little bit, so before anyone goes off and tries to discover or synthesize a brand new element, we need to understand what an element is. So elements are any substance that is made from only one type of atom. For example, I have hydrogen here, which is atomic number 1. Hydrogen is only made of hydrogen atoms, which have one proton and one electron. Likewise, atomic number 2, helium, has two protons, two electrons, and two neutrons within its atom. You might have already noticed as well that the atomic number is equal to the number of protons you would find within the atom of that element. Each element is represented by one or two letters. For example, hydrogen is represented by H and helium is represented by He. We call these representations chemical formulae, and you can find them on the periodic table. This is a topic that I want to cover in a later video. However, you could do a little bit of a Google search now and you can bring up the periodic table for yourself. So here's a quick fire round of some elements, their atomic number, and the letters used to represent. So we have atomic number 1, hydrogen, represented by a H. Atomic number 2, helium, represented by He. Atomic number 6, carbon, represented by C. Atomic number 8, oxygen, represented by O. Atomic number 26, iron, represented by Fe. Atomic number 79, gold, represented by Au. And finally, my favourite element, atomic number 99, einsteinium, represented by Es. Fun fact, the Au that represents gold on the periodic table actually stems from the Latin for gold, which is aurum. In the real world, some of these elements don't really like to exist on their lonesome. A great example of this is oxygen, which is represented by an O. This O means that there is a single, unbounded oxygen atom floating loose and solo. However, elements like oxygen don't like that. They want a relationship. They want commitment. So they find a fellow oxygen atom to bond with. Once these two oxygen atoms have bonded, they form a single molecule of oxygen. This is represented by O2. This O2 means that two oxygen atoms have bonded together, chemically forming a molecule. So not only are there hundreds of elements, but there are literally billions or even trillions of combinations of molecules that can be synthesized. Molecules are a combination of atoms. They can be the same type, like our O2 example, or they can be made from various different elements. Let's take a look at a close to home example. This is an experiment that you can do at home right now. All you need is a cup and a tap. What you need to do is go over to the tap and pour out some dihydrogen oxide molecules, otherwise known as water. Yes, water is a molecule. It's composed of 2 hydrogen and 1 oxygen atom chemically bonded together. Since it's made of 2 hydrogen and 1 oxygen, it's represented by the chemical formula H2O. Here's another example of a molecule you've probably seen in your life. At some point in your life, you've probably left something made of iron or steel outside. If you haven't, go do it. Just make sure it's something like not valuable. Make sure it's not like your perfectly maintained stainless steel bike or your parents' perfect iron bar collection. If you leave this iron out long enough, it starts to form a molecule, rust. So rust is a molecule that forms when iron atoms bond with the oxygen atoms in the air. So what is the chemical formula for rust? Well, it's made of 2 iron and 3 oxygen atoms. So what do you think the chemical formula will be for this molecule? Since the reaction takes place with 2 iron atoms and 3 oxygen atoms, it forms the chemical formula Fe2O3. The number of atoms within the molecule are always represented by the subscripted number. For example, in our Fe2O3 example, there are 3 oxygen atoms, which are represented by O3. So let's rewind a bit. Let's take a look at our elements and our atoms. There was a reason that I mentioned the charge of the subatomic particles earlier on. Sometimes atoms can be clumsy, or they can give their electrons away, or they can be really greedy and steal electrons from other atoms. Radiation, reactions, and a whole number of things can cause atoms to lose or gain electrons. So let's take a look at our hydrogen atom again. With a little bit of radiation, we can knock that electron off and create something called an ion. An ion is an atom that has either gained or lost electrons. And the process of turning an atom into an ion is known as ionization. Ions have either gained or lost a few electrons, which changes the overall charge of the newly ionized atom. So for example, back to our hydrogen atom, we knocked off the electron that was orbiting it. This left the hydrogen atom positively charged, as within the nucleus there is 1 positively charged proton, and now there is no electron orbiting it to neutralize that charge. This ion would be represented by this, H+, the plus showing the overall charge of the ion. So do another ionization, this time with our greedy little friend oxygen. So here we have oxygen, which has now gained 2 negative electrons. This would change the overall charge of the ion to negative. This would be represented by O2 negative, as it has picked up 2 negative charges from the 2 negative electrons it picked up. This would mean that we put the 2 in front of the charge of the ion, the O2 negative. So that is all for today's look into atoms, elements, molecules, and ions. In our next virtual chemistry, we'll look at the bonding that takes place within these molecules and the mixtures of different elements. If you'd like to consolidate some of today's learning, there is a worksheet and an answer sheet linked down in the description below that you can do at home. With that said, it's time to pack up, subscribe, and I'll see you in the next video. Dismissed.
Hi everyone, Mr. Thomas here, and welcome to the Blooper Section. This is a section I like to add on to the end of all of my videos just to prove that it's okay to make mistakes. As a learner, you're bound to mess things up sometimes, and that is completely fine. It's through practice that you make perfect. So, here's a montage of all the times I messed up producing this video for you today. So I want you to sit back, relax, and enjoy.
You picked up might have been made of metal, or it might have been made of plastic. But regardless of that fact, every single object in the known universe is made of atoms, the smallest building blocks of everything. Boom! Oh, did it that time though, didn't I? It is roasting. So let's start today's video by looking at atoms. These are the smallest building blocks of every element in the universe. And here, and now let's change it to helium. This now has 2 positively charged protons, 2 negatively charged electrons, and 2 neutral neutrons. Oh, I like that. 2 neutral neutrons. That's going to be an absolute pain to say. Oh, Jesus. Oh, this script is difficult. I love chemistry, don't get me wrong, but some of the words you have to say, unanenium, 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 unanenium. If I can do this right the first time, I'm going to be buzzing. If I do it right the first time, I'm going to go like that in the video, just a little thumbs up. No, I won't, that'll be too obvious. You know what? Here's what we're going to do. Unanenium, unanenium, unanenium. That is a really difficult word to say. If I do it right, I'm going to hold this in my first take. If I do it right, you know, because I'll have the ruler in my hand.